In 2b, we have to solve this by factoring. The factorization pattern that I recognize right away is that this is the sum of two cubes. So we take the cube root of the first thing, which is 4x. We take the cube root of the second thing, which is plus 1. And then we multiply it times the first thing squared, which is 16x squared, minus the first thing times the second thing. So that's minus 4x times 1, which is 4x, plus the second thing squared, which is 1 squared, which is 1. This is equal to 0. In order to solve this by factoring, what we do is we set each factor equal to 0, because we know the simple rule that if you multiply times 0, your answer is 0. So either this factor 4x plus 1 has to equal 0, or the 16x squared minus 4x plus 1 has to equal 0 in order for your answer to be 0. So really it's a very simple idea that if you have two numbers that are multiplied together and get an answer of 0, one of the other numbers has to equal 0. So I'm setting up that scenario. In this first situation, in order for us to get a factor of 0, that means 4x would have to equal a negative 1, and that would force x to equal a negative 1/4, which means if I plugged a negative 1/4 into this value for x, we would definitely get a 0 for this factor, and 0 times whatever this number is equal to 0. So we found that one. The second one's a little bit more challenging because it's a quadratic factor, and we have to solve a quadratic equation. Now our choices are factor and a quadratic formula. And just by inspection here, I don't see any good combinations of 16 that'll give me a sum of 4. So what I'm going to do is quickly go into the quadratic formula. So I'm going to use the quadratic formula, which never fails us. It can always solve a quadratic. So we're going to go the opposite of b, which would be a positive 4, plus or minus the square root of b squared, which is going to be negative 4 times negative 4, which is 16, then minus 4 times a times c, so it's 4 times 16 times 1, which is 4 times 16, which is 64, all over 2 times a, which is 2 times 16, or 32. So I did a little plugging, a little chugging at the same time, so we got 4 plus or minus the square root of, and now we're going to have a negative, and it's going to be a negative 48 all over 32. So now it's going to be a matter of simplifying that radical in our fraction. So at this point, I'm going to start splitting up my fraction. It's going to be 4/32 plus or minus. Now it's going to be something over 32, and I'm going to go over here and start thinking if I can find, and I know it's an I because it's the square root of a negative, square root of 48. So I got to start thinking of perfect squares that go into 48. Well, 4 does, but there's a bigger one, which is 16. So 48 is 16 times 3. I'm just rewriting it as a product. And the square root of 16 is 4, so that square root of 48 becomes 4 times the square root of 3. And now I can reduce each of these. So x is 1/8 plus or minus, reduce these, 1/8, or the square root of 3 over 8i. So here's my here's two solutions. There's my third solution, and because it was a third degree polynomial, that's the total number of solutions I should be looking for. So I have solutions of a negative 1/4, and then two solutions where they are 1/8 plus or minus the square root of 3/8i.